Good evening, ladies and gentlemen. Good afternoon, ladies and gentlemen, panel of judges and timekeeper. My name is Alao Jeremiah. I am the group leader of Group 1, and the title of our project is Human Following Robotic Car. Now, the Human Following Robotic Car is a device that was designed. Human Following Robotic Car. The Human Following Robotic Car is a project that was designed to assist individuals by autonomously following humans around by carrying loads and to reduce manual labor. The Human Following Robotic Car is a project that can be used in warehouses, it can be used in farmhouses, it can be used in shopping malls, and in a lot of applications. Let me give you an example. In a farm, for example, where they are harvesting crops, they have to go around the farm to take every crop and in order to move it to the store. The Human Following Robotic Car, the concept, the way it is applied, it is that as the person is harvesting the crop, for example, they can put it into the carriage and then to follow them all around the farm till they are done with harvesting. And its application is that it reduces manual labor. This concept is used outside the country for elderly people. You know, someone that is around 80 years, that person cannot move load up and down effectively. So the concept of Human Following Robotic Car is to move goods and services effectively while also reducing manual labor. During our time of designing the project, we faced some challenges. There are limitations to the car. For example, the one we designed uses an ultrasonic sensor and an IR sensor. Therefore, it has difficulties in differentiating which human to follow. So the modification that you can use to improve this is adding a camera to ensure to add image recognition software using an AI in order to understand that, okay, if there are two humans in front of me, there is a specific human that I'm meant to follow during my course of progression. So those are the limitations of the Human Robotics Car.
You need your bag.
Please, can you let's see your work.
Help to raise the leg. The leg, cut it off, raise it up.
So to add to what my leader said, the components you actually made use of, like the IR sensor now, has issue with light. If it is in a very bright environment, it tends to give signal to the motor driver and the Arduino board. So that will actually alter the movement. The left IR sensor is for it to move to the left direction, and the right IR sensor is for it to move to the right direction. Then the ultrasonic sensor is for a straight movement. So the ultrasonic sensor actually is divided in two locations, the minimum location and the maximum location. So when the maximum location is attained, the robotic car tends to move along with the human. But when it is behind the minimum location, it tends to stop, and that will actually alter the movement. So I want to start with the as you can all see, the first ultrasonic sensor, which is the left and the right, both of them, the IR sensors, are both not detecting any light signals for now, due to the fact that there's no enough exposure of light on the IR sensors. So you can actually allow it to move in two directions now. For this, that's for the turning in the right direction, and to move left, you actually place your hand in this one. Now, the reason why we are making use of our hand to direct it is due to the fact that we did not have enough capital to actually make it a bigger one, and the use of camera. We actually made use of just the ultrasonic sensor, the IR, our motor board, the Arduino, our batteries and switch, and also the motor. Now, for the straight movement, when this position of the ultrasonic sensor is attained, it tends to move in a straight direction, as you can see. But when the minimum direction when it actually attains the minimum direction, it stops. Now this is where it moves. When it gets it, you can see that it stops. If I move further, it comes from 20 years. Thank you, sir.
No. You can start, please. Let me see whether my panelists here will have some questions to ask you. Let me start.
Sorry, let me ask, what's the distance for the sensor to pick?
The distance for the distance?
Yes.
20 centimeters.
The maximum is 45.
So, how sensitive is it? Because from what your presentation said was, it says it's going to be used to lead loads and.
Yes, sir.
That's what the carriage.
Oh, okay. You didn't do it. Why didn't you do the whole thing now?
When it was showing the distance, these are the
All right, it's a good. Let's give a round of applause for us. It's a good presentation. I like the concept, but I think you need to do more because what you've explained is a bit skewed from what I've seen there. So there's a need for us to do more. But it's a good presentation. It's a very good concept, and I like it because you're looking at technology to drive activities, which is very, very nice. Farming is the main thing now. And that's what's going to say. It's a good thing.
Another question, please. Let me see what you have.
Sorry. In a situation where the sensor malfunction, what do you do in that situation? When the person is at the front and the sensor malfunction, how does it stop? Or what is the... In the sensor, you say it's following the human at the back. So in a situation where the sensor stops working or have a little fault or something happens to the sensor, what is the question there?
When we were coding it, we made is that we use both the 2IR sensors and the ultrasonic sensor in order to create a stop situation. For example, if both IR sensors detect a human, it will stop. And then the ultrasonic sensor, if it's less than the minimum distance, it will stop. Therefore, even if the IR sensor malfunctions, we also let the ultrasonic sensor have a sort of state where it can stop from colliding with the human being.